This is Algebra 2, Chapter 6, Section 2, in which we will be studying inverse functions and relations. An inverse relation is the relation that's formed by exchanging the x and the y values in each ordered pair. The inverse idea is basically swap. Okay. So here is a relation, -8, -3, -8, -6, -3, -6. And they tell me they're the coordinates of a right triangle. Our job is to find the inverse of this relation. Well, the relation as it is -8, -3, -8, -6, -3, -6. The inverse of that relation would be to switch their places. So the -8 and the -3 trade. -8 and -6 trade. -6 and -3 trade. Note the symbol r with the little -1. It looks like an exponent, but it's really not. That symbol means inverse of r. Okay, having a -1 there stands for inverse. It's not a power. Okay, mathematicians really probably should have come up with a different notation for it, but they didn't. I wasn't there at the naming convention, so not quite that old yet. But that -1 means inverse. That's the key. Now, just like relations, functions can also have inverses. In fact, a lot of them do. Sometimes, though, the inverse of a function is also a function, and sometimes it's not. There's a way to tell from looking at the graph, and it's called the horizontal line test. If you draw a horizontal line, if you take a horizontal line and go across the function and it never meets more than once, then the inverse will also be a function. If it does cross more than once, it won't be a function. So I have my trusty horizontal line here. If you're playing along at home, an uncooked spaghetti noodle would be a good horizontal line because you can move it quickly. You know, a straw, a pencil, something. But here's my trusty horizontal line, and I'm going to take it across my function and see if it ever crosses the function more than one time. All the way through, it never crossed more than once. So this one is, the inverse of it is a function. Now this guy, my horizontal line is crossing this function twice all through here, right? So this one, the inverse is not a function. So when they throw at you to use the horizontal line test, that's what they're looking at. Is draw a horizontal line across it. Like I say, an uncooked spaghetti noodle is a great horizontal line. It also works for a vertical line too. All you have to do is rotate it. If it crosses more than once, then your inverse is not a function. There we go. Now, when they give us a function, they're going to ask us to find the inverse of it. And what they're going to need us to do is use algebraic skills to find the inverse of a function. This is a 4-step process, and I'm going to give you the 4 steps right here, free of charge. Step 1, they gave it to us saying f of x equals. Let's rewrite that. F of x, turn that into a y. Makes life easier if we don't have to carry around all those extra symbols when we can just write a y. Now, step 2 is to exchange x's and y's. If it used to be an x in the problem, make it a y. If it used to be a y in the problem, make it an x. Just trade their jobs. Step 3 is the longest step. Solve the new equation, get y by itself, whatever you have to do to get y alone. And then finally, change your y, because it was a function notation to start with. We have to change it into an inverse function notation. Remember that -1 power? That means inverse. So we have to switch it to inverse function notation. So we're going to do a couple of these. Okay. Here's a function, x minus 3 over 5. Step 1, change that f of x into a y, just to make it easier to work with. Step 2, trade the x's with the y's. This used to be a y, it became an x. This used to be an x, it became a y. Now our job is to get y by itself. Well, first we need to multiply by 5 to get it out of the way. We don't like fractions, so we get rid of it. Then we need to add the 3 over. And now we've got y by itself. Now we just need to turn it into inverse function notation. So I change the y into f inverse of x. And I switched the sides of the equation just because I was always taught to write it this way. I guess it doesn't really matter, but I just wanted to stick with what I know. So switch it to a y, trade their places, get y alone, switch it back to inverse. Let's do one more of these. We have f of x equals 3x squared minus 5. First job is to switch that f of x into a y. Now change x's for y's. So I switched everything that was a y into an x and everything that was an x into a y. Now I need to get y alone. Add the 5 over. Divide by 3. Take the square root. And technically this probably should be plus or minus, but since we want to make sure we have a function, we do just the positive square root. And now switch it back to inverse notation. And I moved it over so it would have room on the page. And presto, we have our inverse notation square root, or our function, inverse function notation there. So what did we do today? We dealt with inverse functions and inverse relations. We basically switch x's for y's and switch y's for x's. We talked about the horizontal line test, and then we did some algebra to get to inverse function notation. If you had questions along the way, hopefully you wrote those down, bring them in to ask, and we'll see you in class.